Hey Dragons, this is our Unit 3 review video. I'm going to do the first 5 and then cut it off and then make a second video for the last 5. Make sure you try these first before you look at the video. Here we go. Write the equation that best describes the relationship between time t and the distance d the tramway is from the peak. Now the first thing I notice here is that this is a line. Okay, so if you have a line, you should start with y equals mx plus b, slope-intercept form, where y is the output, m is the slope, x is the input, and b is your y-intercept. So as I take a look at this, I know that the horizontal axis is traditionally the x, and it has been replaced with time. If you remember what I've said about time, time is always independent. So my x variable will be replaced with a t variable for time. If I look on my traditional y vertical axis, it has now been replaced with distance, and I'm going to use d for distance. So what do I need? I need a slope, and I need a y-intercept. Well, the y-intercept, I believe, we can simply find by observation. The y-intercept is right there on the y-axis. My scale is 500. Every mark is 500. So 4,000 plus an extra mark is going to be 4,500. So by simple observation, looking at the graph, my y-intercept is going to be 4,500. Now, a lot of students, when they go to find the slope, they'll try to make a slope triangle, and they'll say, well, I think this point right here is 4 comma something, and that's where they get confused. Folks, take a look at this picture. There are 2 very clean points, and they happen to be on the x and y axis. You can do a rise and run from any points on the line. Why don't we use the 2 points that we clearly see right here? And let's make our slope triangle using these points. We'll go down 4,500 and we'll go right. I believe that's going to be 15. So let's go down 45. That's going to be 4,500. Remember, if we go down, and then we're going to go to the right 15, and that's going to be positive. So my rise over run is going to be a negative 4,500, and my run is going to be a positive 15. And if we crunch those numbers, we'll see that that is going to equal to a negative 300. And after we do this, we take a step back. It says write an equation. You got an equation right here that best describes the relationship between time and distance. We step back and go, hey dude, I'm done. And we are. So the answer is what you see in the box. Alright, problem number 2. Jennifer reluctantly agreed to participate in the band fundraiser. Before she contacted anyone, she purchased 2 orders for herself. To chart her effectiveness, she tracked how many people she contacted and the number of orders received. The table below shows her results. Write the function that best models the relationship between the people contacted, P, and the orders received, N. Well, let's go ahead and take a look at the change in X and the change in Y. Remember, they may say people right here, but this is really your input column, and it may say number of orders N, but this is really your output. So again, remember, first column input, second column output, X, Y. If they rename it, so be it. So if we take a look at the rate of change from here to here, to go from 2 to 4, that's an addition of 2. Well, let's look over here. What happened to my orders during that change? It went from 5 to 8, so that is a change of 3. Now, if I look at the change in X and change in Y in the form of rise over run, remember we rise on the y-axis. So my change in y is going to be 3. That's my rise. And my change in x goes along the x-axis. That would be my run. So my slope from just these two is going to be 3 over 2. Do I get that same ratio by repeating the process using different numbers? From 4 to 6, that's going to be plus 2. From 8 to 11, that's plus 3. Rise over run, 3 over 2. Yep. And let's try one more time. I like this because I get to use different colors. 6 to 8 is a change in 2. And 11 to 14 is a change of 3. 3 over 2. All of these have a change of 3 over 2. So that tells me that it's linear, that it's a line. And what did we start with in the previous problem, knowing that we had a line? We started with y equals mx plus b. So on this, let's start the same way. So we start with y equals mx plus b. We know our slope is 3 over 2, so that goes in the place of m. Okay? And y was replaced by the letter n, so I'm going to do that right here. N equals. And x was replaced with the number of people, p. The only thing I'm missing is my y-intercept. Now here's a cool little trick that you can learn real fast by looking at the table. Instead of going 2 to 4 to 6 to 8, we know that a y-intercept has an input value of 0. So let's go backwards and try to get a 0 up here. So 8 minus 2 is 6. 6 minus 2 is 4. 4 minus 2 is 2. What's 2 minus 2? 2 minus 2 will give me a 0. And if you notice, I can just continue the pattern here. This is what I want. So if I'm going to extend this pattern to 0, let's do the same thing over here. But we're not going to take away 2. That was for the x column. We're going to take away 3 because 14 minus 3 is 11. 11 minus 3 is 8. 8 minus 3 is 5. So what's 5 minus 3? And that would be a 2. Kind of hard to see in there. So I have the ordered pair 0, 2. Don't worry, you're not tardy. 0, 2 is my y. That's on the y-axis. And so that's what I put right here. And now we have the function. Now, if they want function notation, remember n is the function of p. So I would write f of p is equal 3 over 2 p plus 2. So if they want the equation, it's right here. If they want function form, it's right here. Either one is acceptable. Okay, go to number 3. So on problem number 3, Nathan is selling hats. He spends $250 on advertising to get his business started, and he earns $30 in profit for every 6 hats he sells. Write the function that Nathan can use to determine how much money his business has made P after selling H hats. Well, this is going to wind up being a linear function as well. So we're going to start with this. So we're looking for a starting amount. Do you see a starting amount? I do. Nathan spends $250 on advertising. That's a one-time advertising setup charge, whatever you want to call it. This is a one-time payment. Now remember, I highlighted spends as well. So that means that he's already in the hole $250. He no longer has $250 in his pocket. So I'm going to put a minus 250 because he has to sell some hats in order to make up this deficit so that he can make a profit. So it's important to realize that spending money means you're subtracting it as your initial value, or you're using a negative value as your initial value. All right, the next thing here, they're going to try to trick you here, right? So you're probably looking at, well, I need a slope, so I'll put 30 right here because that looks good. But look, he earns $30 for every 6 hats he sells. So how much is that per hat? $30 for every 6 hats is going to be $5 per hat. Hey, I have something purring at us. That's my rate of change, $5 per hat. So that 5 is going to be my slope. And I have my input and output. You notice they say how much money. What do you know about money? Is money always dependent or independent? Is money the y or the x value? If you remember what I had in class, money is always dependent. So my money is right here, and money is profit. So that's going to, P is going to take the place of y. And I have $5, and x is going to be the number of hats. That is the independent variable, minus 250. And hey, look what I got. I got an equation that talks about $5 per hat. He's selling hats to make money, but he has to make up a $250 that he spent on advertising. And then once this becomes positive, he gets a profit. And so there's the equation. If I go in function notation, P is a function of H. So the number of hats equals $5 H minus 250. Again, equation right here, function notation right here. Those are interchangeable. They're the same thing. Problem number 4. During a spring evening, the power went out for 12 hours and Sally lit a candle. When the power went out, the candle was 11 inches tall. Every hour she measured the height of the candle and graphed the data below. First of all, the numbers aren't very good, so let's go ahead and put those in. Every 2 marks is going to be 2. And so let's make those clear. And then down here, every mark is single, and that's a 5 down here. Okay. Now you notice up here we're dealing with time, and we're dealing with height. So where does time go on my XY axis? Which one is it? Does time go with the X, or does time go with the Y? That's right. Time is always independent. Time will go down here. So this is my time in hours. And so that means this has to be the height in inches. Now you notice right here, they ask us some questions. Using the above graph, what is the rate of change? Well, that's the slope. All right, so if I go from this is 1, 10. If I go down 1 and right 1, let me go ahead and put that in, down 1 and right 1, I get to the next box. Down is negative, right is positive, rise over run. My slope is going to be a negative 1. What is the initial amount? Remember, the initial amount is the y-intercept. And so we look up here, we're going to have to continue this, right? This is 1, 10, so if I continue this slope triangle, I'm going to go up right here. And you can see that I'm at 11, and remember this is inches. So this is going to be 11 inches. What is the 0? Remember the 0 is the x-intercept. So once again, I'm going to have to come over here and extend, keep going down. Be careful here, and go down 1 and right 1. Down and right. So I'm at 2, 9. Down and right. I'm at 1, 10. I guess I could extend that. And then finally, if I go down 1 and right 1, oh, looks like I'm at 11 hours. So my y-intercept is going to be 11. Again, the independent variable, independent Dix-Roede, your x-axis is independent, so that would be my time. Time is always independent, and in this case, the height depends on how long the candle's been burning. And there you go. Same thing, same type of questions over here. This is Cheryl's walk from her house to Bridget's house. It's a little more clear. We have a clear y-intercept and a 0. So let's fill that in. The y-intercept is 2,000. X-intercept is 16. And the slope, again, instead of trying to go find some points over here, use the points you have. You got that one and that one. Make one grand